let's look at some algebraic properties of norms, which will be really useful. So once we have a set of norms, we can also form other norms using those other combinations. The first property which we're looking into is if alpha norm and beta norm of x are vector norms on some vector space, then the norm defined by max of alpha and max of beta as a norm. Is a vector norm. So if you have two vector norms which are valid, you can create another norm by taking the max of those two norms. So it is literally easy to prove. So I'm not proving positive definiteness, which is pretty straightforward because 1 and 1a are obvious. And the definition is the norm. We can prove homogeneity. Right? So we have alpha times x is max of alpha times x. Okay, let me call this a times x. It's not confused with the alpha. A times x, comma max of a times x. So the b norm of a times x. So see, so then yeah, there's no max here. So we already know by homogeneity, this will be max of modulus of a into a modulus of x beta. So alpha norm of x. So this is actually, this is a positive quantity, this is a positive quantity, and these are positive quantities, right? So whenever we have, look at some, in general, when you have a times b plus a times c, the max of these two numbers will be a times max of c, right? So we can take mode A outside, max of this quantity, which in fact, this is actually x star. So homogeneity is also satisfied. Now we have to look at triangle inequality. Start with x plus y star is same as max of norm of x plus y, alpha norm of x plus y, and beta norm of x plus y, right? But this, in fact, this satisfies triangle inequality. Since alpha and beta independently they are norms, they satisfy triangle inequality. So we can say this is less than or equal to max of right? So we have max of two quantities, and yeah. Now what should we do? We have to find. Let's take this as u1 and v1. This is u2 and v2, right? This is something like max of u1 plus c1, comma. Note that these both of them are positive quantities, okay? u2 plus v2. So this maximum will be always less than or equal to max of u1 plus u2, comma v1 plus v2. Sorry, max of u1 plus u2 plus max of v1 plus v2. I hope it's clear. Let's take an example, like example of 5 plus 6 and 7 plus 2. The max of this is max of 11 and 9, which in fact is 11. But if you take max of the first term and first and seventh term, which is 7, plus max of the second terms put together, which is 6, is in fact 13, which is greater than this. So we can use this property. Use this property and say this is max of, this is just some manipulations, this beta plus max of norm of alpha norm of y plus beta norm of y, which is again less than or equal to norm of x star norm of x plus star norm of y. This is a triangle inequality. This is also proved. So like this, we can prove triangle inequality. So this is a valid norm. So the one thing to note here is the note which we can make. Minimum of x alpha and x beta is not a valid norm. We can easily prove this using a counterexample. How do you prove this? Is a counterexample. Okay. Yeah, this is the first property which we're looking at. Now we can look at the second property. If this is also an important property which we'll use later in this course, is the vector norm. And Cn, and T belongs to Cn cross n, is non-singular. Then the norm defined like this is equal to T times x is a norm, is a vector norm. So we can form a new norm using a matrix. Also, we have note need not be equal to norm of X in general. There's a specific case in which these norms are actually equal. That is a case where if T is orthonormal, then T Hermitian T is equal to the identity. In that case, the norm of Tx L2 norm that now this is a very specific case. The norm has to be L2 and T has to be orthonormal. Is Tx all Hermitian is Tx into Tx, which is in fact X Hermitian, T Hermitian, Tx. This will be equal to I, dx Hermitian X, which is same as L2 norm of X whole squared. Only in this case, these norms are equal, but not in general. So I'm not proving this that this is a valid vector norm. It's easy to prove. These are two algebraic properties which we can notice. There are many more, but currently we're discussing these two properties for vector norms.